So here we go, Snell's Law Lab Part 2. We're going to plot these data and get the index of refraction. But before we start to figure out why we're doing what we're doing, I'm going to show you here with a little algebra. Normally in this class when we plot our data, we put the independent variable on the horizontal axis and the dependent variable on the vertical axis. And that's just by convention. It makes it easy. Usually y depends on x. And in our experiments, we are able to change in this experiment, our independent variable was the incident angle. That was theta 1. And the dependent variable was the refracted angle, theta 2. However, from this graph, we are hoping to get the index of refraction for the unknown material. We're looking for N2. So I'm hoping to get N2 from the slope of our graph. So if I look at the equation for Snell's law is N1 sine theta 1 equals N2 sine theta 2. I'm hoping that the slope of the graph will give me N2. So I'm going to manipulate this algebraically, this equation, to see how I could solve for slope or put this into, I'm going to solve for N2. So here, if I divide both sides by sine theta 2, I now isolate my N2. Okay, so to get N2, I need to have N1 sine theta 1 divided by sine theta 2. I know that slope is y, change in y over change in x, or your y values divided by your x values will give you the slope. So my N1 sine theta 1, these need to be the y values. My sine theta 2, these need to be the x values. So remember, slope is rise over run. So rather than plotting my dependent variable sine theta 2 versus the independent sine theta 1, we're going to invert that. So for this graph, to get N2 from our slope, we are going to plot N1 times sine theta 1 versus sine theta 2. So these will be our x values, these will be the y values, and the slope of this line will give us N2. Fortunately for us, N1 was an error, so that's equal to 1.00, and any number times 1.00 is itself. So if we plot sine theta 1 versus sine theta 2, we should get a linear relationship. The slope of this line will give us the index of refraction, the N2. So we'll go into Excel and go to Insert, Charts, Scatter Chart. Hopefully it comes out blank. If it doesn't, just right-click, select Data, make sure you clear all the entries, go to Add, Series Name. This will be Unknown Index of Refraction. We'll just call this relationship, we'll just call it after the lab, the purpose of the lab. The series x values, click the equal sign. The x values, remember we're going to do N1 sine theta 1 divided by sine theta 2. So sine theta 2 will be our, this goes on to row 7, our x values. Sine theta 1, these will be our y values. And you hit OK and OK. Now we're going to go to axis titles, of course. Trend line, click on, more options, and with the green vertical bar selected, display equation on chart. You know you've done things correctly if your slope value, which is just the number in front of the x, let me make this larger, So it's only the number in front of the x, that is your slope value. All the rest is not the slope. So if this number is greater than 1, you've plotted correctly because the index of refraction should be greater than 1. We'll title this sine, open parentheses, insert symbol, insert the theta symbol 1. These are the sine of the the incident angles, and it's a unitless number, so we can sine of anything is a unitless number because it's a ratio, so you can leave it like that. This will be sine of open parentheses symbol theta 2. Oh, and I guess I'm gonna in front of here I'm gonna do n1 for the vertical axis. This will be n1 times sine theta 1. And the slope of this line gives us the index of refraction. When you have this completed, save this Excel file, submit this to the hub, finish out the remaining questions on the physical copy of the lab, turn that into the basket, and then you are done with this activity. Thank you guys for watching and study well.